and welcome to a review of rigid motion and transformations, triangle congruence, angle theorems, and line theorems. Too many words. Make sure you have your compass and a pencil. This was done by Janae Ballingall, Emily Scott, and me, Jade Weldy. Alright, triangle congruence in terms of rigid motion. Using transformations, you can conclude that two triangles are congruent. You can use translation, reflection, rotation, but you cannot use dilation. Ooh, spinny. And these are the four types of triangle congruence you see. There's side, 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 with three pairs of congruent sides, side, angle, side, where two pairs of congruent sides and one pair of congruent angles. There's just one side congruent to one side, one angle congruent, and then another side. And then there's angle, side, angle, two pairs of congruent angles and one pair of congruent sides. And then side, angle, side, side, angle, angle, two pairs of congruent angles and one pair of congruent sides. These sides not between the pairs of angles. Here are some review questions for triangle congruence. Alright, so for the first one, you can see there's a line right there. That means those lines are congruent, and this angle is congruent to this angle. They're both 90 degrees. And then this angle right here is congruent to this angle right here. So that one would be side, angle, side. And then for the next one, try it on your own. I am bored of waiting. So if you look at it, there's a side congruent to a side, there's an angle congruent to an angle, and then there's another side congruent to another side. So that one would also be side, angle, side. I don't know why I said also. I'm not sure, but it's side, angle, side. An isosceles triangle. An isosceles triangle is a triangle with two equal sides and two angles that are of equal measurement. So if you look in your notes, an isosceles triangle is a triangle with blank. That would be 2. And then the centroid. Centroid is this dandy little guy in the middle of a triangle right there. Well, how do you find a centroid? Well, using your handy-dandy compass, you find the midpoint of each line segment, and that is a lot of work. You gotta find the midpoint of BC, CA, and AB. And then once you find the midpoint of those, you connect that midpoint to a vertice. So the midpoint of AB connects to the vertice of angle C. And then where all of those triangles meet in the center is the centroid. Line theorems and angle theorems. Yay! Vertical angles are angles opposite to each other with two intersecting lines in between. That is the first picture you see right here. These are all vertical angles. And then corresponding angles. The next picture. These are angles that are on the same side of the line with matching corners. So D matches with H, F matches with B, I believe that's an F, and A matches with E, and C matches with G. I should have done those in different colors. Let me do that. Dun, 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 dun. This is taking too long. Let's do this one in blue. Who doesn't like blue? Everyone loves blue. Blue is a nice color. And then the last one, alternate interior angles. These are angles on the inside of congruent, and if they are opposite of one another and add up to 180 degrees. These are the most frequently used in proofs and many other types of geometry problems. So you see, this angle is on the inside, and this angle is also on the inside of the transversal. But they're alternate of each other. So A is not on the same side as 2, and B is not on... Well, they are on the same side, so that's why they're not alternate interior angles, because they're not alternate. Review questions for line and angle theorems. Which angles are vertical to each other? Sorry, excuse that. We had to pause, and I kind of forgot what I was doing. So, I'm just going to start over on this slide. Review questions for line and angle theorems. Sample question. Which angles are vertical to each other? A, angle 1, angle 3, 2 and 4. B, angle 1 and angle 4, angle 2 and angle 3. Or C, angle 1 and angle 2, angle 3 and angle 4. And the answer is at the bottom. A. Angle 1 and 3, 2 and 4. So 1, 3, and 2 and 4. Now try it on your own. See what you get. So what you should have gotten was pretty much the picture down there. You could have put A and B are congruent, and C and D. Those are vertical angles. Oh look, we need your compass again! Line segments. This is for bisecting a line segment. To do this, you place your compass on point A, stretch it out over here. Doesn't have to be exactly there, but just move your compass out over here and then draw an arc. I would do it with you, but I don't exactly have a compass on me for the computer. And then keeping the compass the way it is, do not change the measurements. Move it over to point B and then make your arc. Same thing. Uh-oh, that was not meant to happen. Okay, that was an accident. And then where those two lines meet should be in the middle of the line segment, which is, you can label CD or 3 and 4, whatever you want to call it. And that's how you bisect a line. Rigid motion. Alright, rigid motion is reflections, translations, rotations. And this still does not include dilation. So translations would be what you see right here. I mean, reflections is what you see right here. It's where you take something and you flip it over an axis. In this case, you flipped it over the x-axis. So, 0.0, -3, ended up over there, and that ended up over there, and that ended. And then the next one, rotation, is over here. I'm skipping around. Don't mind me. This one is rotation. So what you can see here, you have your little pinkish purple triangle moved over there, and it can also be moved that way, and it can also be moved that way like shown in C, and then it can even map back onto itself like shown in D. And then moving back to translation. Translation is when you just move it around the graph. So right here you see AB, triangle ABC was moved down to A prime, B prime, C prime. And then congruent figures, that's this guy right here. They're the same size and shape and can be proved as congruent through rigid motion. Review questions. Lots of fancy movement going on. Which rigid motion will prove that triangle ABC is congruent to triangle DEF? Give you a second to think about that. Okay. The answer is C, a rotation. Now, do it on your own. Which rigid motion will prove that triangle ABC is congruent to triangle DEF? A, rotation. B, a reflection. C, they are not congruent. And the answer is B, it's a reflection. That was the end. By the way, just to let you know, if you look in your notes, there's some funny sounding things where you see, like in the worksheet, it says unites instead of units, and there's one spot where it does not say theorems. It just does not say theorems. It says thermos of angles. And don't mind that. That was just Janae and her dyslexia, so everything is okay. Everything is fine. Thanks for watching.